Hi, this is Dr. Thomas, and in this video I want to show you how to simplify complex fractions using method 2. Now, what is a complex fraction? And because a lot of students think we're already working with complex fractions, but actually the word complex really just refers to a fraction with either a fraction in the numerator or the denominator, and sometimes you're going to have fractions in both the numerator and denominator. Method 2 involves less steps than method 1, so I actually prefer using method 2 over method 1, but some students make more sense out of method 1 than method 2, so it doesn't matter which method you use. But in this video I'm going to show you how to use method 2. So method 2 involves a few steps. The first step is to factor the denominators if possible. Then you need to find the LCD for all denominators in your fraction, and the last step is to multiply the top by the LCD and multiply the bottom by the LCD, and we say top for the numerator and bottom for the denominator. So let's start off with a basic complex fraction. So this is a fraction divided by another fraction. So the first thing you need to do here, in this case, since you can't factor, is find the LCD for both denominators. So notice that this is a denominator, 4, and also the 8 is a denominator. So what is the LCD out of 4 and 8? The least common denominator is 8. So you're just going to multiply top and bottom by 8. Alright, top meaning 1/4, multiply it by 8, and multiply 3/8 by 8. Now of course 8 is considered to be 8 over 1. Therefore 8 is considered to be in the numerator. Therefore I can cross cancel here. So if you don't see that, this is the same thing as saying 1/4 times 8 over 1. So you can cross cancel. 4 goes in 8 2 times, 4 goes in 1, 4 goes in itself 1 time. So the answer is 2. Okay? So 4 goes in 8 2 times this 1 is 2. So 2 over. And in the bottom we have 3/8 times 8. These 8's cancel out. You're like a 1 here. 3 times 1 is 3. So the answer is 2/3. Let's do 4 over 3x. So now let's involve some variables. All over 6 over 4x minus 2. Now let's look at the denominators here. We have this 3x here, that's a denominator. Then we have this 4x here. And this 2 is considered to be over 1. So that's if you want to look at it, that's a denominator. 1 is a denominator. So what is the LCD for 3x and 4x? What is the LCD for 3x and 4x? The answer is 12x. 12x. So we're going to multiply this top portion by 12x, and we're going to multiply all of this by 12x. Since it's a binomial, is more than one term, you need to put a parenthesis around it because you're going to have to distribute this 12x. Okay? Let's look at the top portion. We need to see what cancels. Now what cancels are, okay, we have the x cancels here, but also 3 can go into 12 4 times. So now we basically have a 4 times 4 here in the numerator. So it's just 16. Now in the denominator we're going to have to distribute. Let's multiply 12x times 6 over 4x. Now if you wrote this on the side, what happens if you multiply? 4 goes in 12 3 times, and the x's in cancel, so you have an 18. Then you have a minus sign in the middle. 2 times 12x is 24x. Now, can this be simplified in any way? It looks as if it can be simplified because all of these numbers are divisible by 2. Okay, so let's look at this 16. Let's factor the denominator here. The number 2 can be taken out. What other number can be taken out? 6 is the GCF of 18 and 24. So let's take a 6 out. We have 3 minus 4x. And now it's possible that we can reduce 16 over 6 because they both have the number 2 in common. So let's cancel out the 16 and put 8 because 2 goes to 16 8 times and 2 goes to 6 3 times. So the answer is 8 over 3 times 3 minus 4x. So make sure you simplify your answer. But you cannot cancel terms. Okay, you cannot cancel individual terms. You have to cancel factors. Okay, so that's why I factored the denominator in order to start canceling. Alright, let's try 4 plus 1 over x divided by 3 plus 2 over x squared. Again, what is the LCD here? So we have this denominator, we have this x here, and we have an x squared here. Out of those two, what is the LCD? The LCD is x squared. So let's multiply this entire thing. You can put it in the front or in the back, as long as we distribute. And again, what makes this legal that we're multiplying top and bottom by the LCD? Because we're basically saying multiplying that fraction by x squared divided by x squared. And you know that if you multiply times something divided by the same thing, that's equivalent to 1. X squared divided by x squared is 1, just like 1 divided by 1 is 1, 2 divided by 2 is 1, 3 divided by 3 is 1. So long as it's the same thing divided by itself, then the answer is 1, and that makes it legal in math to multiply by a certain thing. Okay, so let's distribute here. X squared times 4 is 4x squared. X squared times 1 over x. Now what happens? Notice that 1x will cancel. So you're just going to be left with plus x. Let's distribute the denominator. X squared times 3 is 3x squared. And x squared times 2 over x squared, notice that the x squared will cancel. And you'll only be left with the plus 2 here. Now, in the numerator, you can factor out an x, but I already see it's not going to cancel out with anything in the denominator, so it's not necessary for you to factor this out because it won't cancel with anything in the denominator, because these are terms down here and you cannot cancel this with this in the top. So this is your final answer. Let's say you had 1 plus 7 over x minus 2 divided by 1 minus 3 over x plus 2. Okay, now what is your LCD? So these are totally different denominators. So the LCD is actually both of those, x minus 2 times x plus 2. Okay, x minus 2 times x plus 2. So that is the LCD. So what I'm going to do is multiply top and bottom by x plus 2 times x minus 2, or x minus 2 times x plus 2. Same thing. And see what happens. Okay, so if we multiply x minus 2 times x plus 2, we get x minus 2 times x plus 2. But here, if we multiply x minus 2 times x plus 2 times 7 over x minus 2, notice that the x minus 2's will cancel. And you'll only be left with the plus sign that's in the middle, 7 times what's remaining, which is x plus 2. Okay? And we'll simplify later. Now we have x minus 2, x plus 2 times 1 again. Then we have a minus sign in the middle. But if we distribute this, notice that the x plus 2's will cancel. And you'll be left with 3 times x minus 2 in this case. Alright, so x minus 2 times x plus 2. Now you should go ahead and FOIL all of this out. Go ahead and FOIL it out and tell me what you get. So you can pause now and tell me what you get when you multiply x minus 2 times x plus 2. Now if you're really good, you would have noticed that this is a difference of squares, factors, so the answer should just end up being x squared minus 4. And then multiply this out, you get plus 7x plus 14. Again, if you distribute this and FOIL it out, you should have ended up with x squared minus 4. And then notice this minus sign here. Please do not ignore the minus sign. Once you distribute, you're distributing that negative 3. Not just positive 3, but a negative 3. So minus 3x plus 6. Alright, so we have x squared plus 7x plus 10 if you put it in descending order. So the like terms here were this negative 4 plus 14. Take the sign of the higher number. Then in the bottom you have x squared minus 3x plus 2. Now are you able to factor the numerator and denominator so you can simplify this even further? It actually looks like you can. So I want you to go ahead and pause this, factor it, and see if you can simplify this even further. Okay, so if you factored the numerator correctly, you should have found factors of 10 that'll give you 7. And I can think of 5 and 2 right off the bat. If I multiply 5 times 2, I get 10, but if I added these two numbers, I'll get the middle coefficient. So we have x plus 5, x plus 2. In the denominator, I see that factors of 2 that'll give me negative 3 would be negative 1 and negative 2. So right off the bat, x minus 1, x minus 2. Now notice that nothing canceled. So either or answer is correct. This is correct. And if you decide to go ahead and factor to make sure, that's even better. This is also correct because these are equivalent to each other. Let's try a plus 1 over a divided by 8. Now this seems like a unique type of complex fraction, but actually we can use method 2 on this fraction as well. So you also first figure out if you could factor, and of course not, and then we find the LCD. The only denominator we really sort of have is this a here. Everything else is considered to be over 1. So let's multiply top and bottom by a. Okay. Once we do that, we get a times a, which is a squared, a times 1 over a. Notice that the a's will cancel. So you just have plus 1. In the bottom you just have a times 8, which is 8a. I know it's tempting, but you cannot factor a squared plus 1. It is a sum of squares, plus sign in the middle. So you cannot factor it, and therefore this is your final answer. Okay, let's try one more. We have 4 over x squared minus 9 plus 2 over x minus 3 all over 1 over x plus 3 plus 1 over x minus 3. So I immediately noticed that you can now factor a denominator in this problem. This x squared minus 9 is a difference of squares. So let's factor it. So it's 4 over, down here, 4 over x plus 3 times x minus 3 plus 2 over x minus 3 all over 1 over x plus 3 plus 1 over x minus 3. So the LCD is x plus 3 times x minus 3, since I have an x minus 3 here, here, and I have an x plus 3. So I can get all of them to basically look the same. That's how I know what my LCD is, if I can get all of them to be x plus 3 times x minus 3. But since we're using method 2, I'm not trying to make them look all the same. I'm actually trying to get rid of all the denominators so I can simplify my answer faster. So let's proceed and multiply the top by the LCD, which is x plus 3 times x minus 3, and the denominator by x plus 3 times x minus 3. Okay, what happens once you do that? Alright, so once you multiply all of this times this, notice that both of these denominators will cancel. So it sort of looks like this. See how all of that canceled and it only leaves 4? I don't like canceling out because I know that I'm going to have to eventually multiply that LCD times the next thing. So I don't like canceling out in this situation. I just like looking at it and mentally seeing what would cancel, and only the 4 will be left. So I put 4 here, got a plus sign in the middle. If you multiply this times 2 over x minus 3, what would cancel? Just the x minus 3's, but you still be left with 2 times x plus 3. Alright, in the bottom, you got to multiply, distribute again. The x plus 3's will cancel, and you only have x minus 3, because x minus 3 times 1 is x minus 3. And again, distribute. The x minus 3's will cancel, and you have plus x plus 3. Alright. If we simplify this, what would... Okay, so we would get 4 plus, I'm going to multiply here. Please don't add 4 plus 2. That's not order operations. You must multiply and add it to the 4. So it's 2x plus 6 here. And here the 3's will cancel. And you have a x and an x. X plus x is 2x. Okay. Then here you have a 4 plus a 6. So you have 2x plus 10 over 2x. I know it's tempting, but you cannot cancel this 2x with this 2x. You cannot factor cancel terms with terms. Okay. You must factor to cancel factors with factors. So let's factor this. I notice that 2 can come out, and that leaves me with x plus 5 over 2x. Now notice I can cancel this factor here with this factor here. So let's cancel. 2's cancel. And we're left with x plus 5 in the numerator and only in x in the denominator. No, you cannot cancel these x's. Again, you must factor out factors in order to cancel other factors. Well, this concludes the video on complex fractions using method 2.